Plus, the other question which was asked was on the cross product. There's an equation you'll get acquainted to when you are in your second view, and that is F is equal to Q into V cross V. What over here we have to take into account is when A cross B vector being taken, A and B are supposed to line a plane, and the resultant, that is A cross B, is a vector which is perpendicular to both A and B. The author said over here that, I'll read the question for you. The author said over here, this again is by Sanvi. So the author says, that F is equal to Q E, that is the Lorentz force we call, QE plus Q into V cross V. And you are to assume F to be 0, net force to be 0. This gets us QE plus Q into V cross V. Taking the first factor to the right, left of equality, minus of E is equal to V cross V. Now, what does this specify? Firstly, E is perpendicular to B, negative of E is perpendicular to B and perpendicular to V. That is what it is to gauge from any student this equation. Then, what is given to us? Given to us is E is along x-axis and B is along y-axis. E is along x-axis. Let us mark it over here. X, Y, Z, one of the many right-hand frame that you can draw for your convenience. This is for my convenience. So I have taken x-axis is B to me. So this is the direction shown. What is next given to us is y-axis. Let me read it again. Suppose E is along x-axis, I'm afraid. E is along x-axis is given to us. E is along x-axis and B is along y-axis. So B is along y-axis. If E is along x-axis, then minus E will be along negative of x-axis. So minus E is this way. And we know that minus E, according to this equation, should be perpendicular to both V and B, which goes in say that V cross B, I have to take V cross B. So V should be outward, B should be upward, then V cross B will be towards negative of V. From here, what we are guesstimating, rather what we are cementing is direction of V. V will be towards Z axis. So this is V to us. V cross B, negative of V. These are the directions. From here, we are to culminate eventuating this question in what direction and with what minimum speed V should a positively charged particle. So in which direction we got it already, and what will be the minimum speed. So from here what we get to see is V cross V. Now V cross V. Remember one thing class, it's not necessary that V and B should be perpendicular to each other. What is necessary is E should be perpendicular to V and B. So it's not mandatory for V to be along Z direction. It should be in a plane, and negative of V from this equation should be perpendicular to the plane containing V and B. So get off, scrape, there should be any angle which is 90. We are not professing it. We are professing there can be any angle. So take that angle, any angle, and equate the magnitude of this vector with E vector. What do we get to see then? We get to see VB sine theta should be equal to E. From here, V is equal to, visible? Yeah. E sine theta, not visible right over here. V is equal to E by B sine theta. So V to B, for V to be minimum, sine theta should be maximum. So V is equal to E by B. Right? That is what being asked when we read. What should be the minimum? Yeah, minimum. So for V to be minimum, sine theta should be maximum, which makes it 1. Therefore, V is equal to E by B. So this scenario is good for the case when you want to give V minimum. Reminding you again, V and B. This equation is not to in any way overread. Please don't read it to be V and E being perpendicular, which is not the case. It's just about the plane containing V and B, whichever plane it may be, negative of E will be perpendicular to it, right? This will be the answer to the question asked. Thank you.